So let's consider the an example of centripetal force. So let's consider famous examples. One that Isaac Newton was concerned with, and that was the moon orbiting the Earth. So Newton was wondering, why does the moon go around the Earth? And so because he realized that the way the forces work, the moon should go off in a straight line. Well, it doesn't do that. It curves around. And so he realizes the gravity is always pulling inwards on the moon. So that pull inwards is going to be the centripetal force. And so that's what I want to know. What is the centripetal force on the moon? Okay, so that means that we need to calculate that. So centripetal force we know is mv squared over r. Okay, well, all we need to know is mv and r. Well, we can look that up. Mass of the moon, 4.346 times 10 to the 22nd kilograms. And r, well, the moon's orbit is actually slightly elliptical. And so I'm going to give you the average value here. So that's 3.844 times 10 to the 20, so 10 to the 5th meters. Okay. So then we want to find v. Well, finding the orbital velocity of the moon is tough. So it's easy to find the orbital period. Period is the time it takes to go around one orbit. And so that's 27.32 days. Well, we can work with that because we know that the velocity is going to be the distance around the orbit. So that's circumference 2 pi r divided by period. So we can figure this out. All we got to do is make sure we have the right units. So we want to use MKS units. So that would be the SI, meter, kilogram, and seconds. So we need to convert the radius of the orbit, 3.844 times 10 to the 8th meters. And we need to convert the days into seconds. That comes out to be 2.360 times 10 to the 6th seconds. So V is 2 pi r t. So V squared is 4 pi squared r squared over t squared. So that means that Fc mv squared over r squared is going to be equal to, so mv squared over r is going to be equal to m over r times 4 pi squared r squared over t squared. So 1r cancels that r up there, and so the centripetal force becomes 4 pi squared mr over t squared. And so if you plug in the numbers that we had here, this comes out to be 6.371 times 10 to the 19 newtons. So that is the centripetal force acting on the moon. Now, later on, we're going to realize that that's due to the gravity of the Earth, which means that if you can figure out the centripetal force, then you can figure out the masses involved between the things. And so in fact, that's one of the ways we determine masses of planets is by simply figuring out the centripetal motion of the moons around the planet and then solving backwards for mass. So this is a classic example that Isaac Newton worked on, and so it's a very fitting introduction to this for us.